You've probably had this happen. You ask an AI a question, and it gives you this answer that sounds so confident, so detailed, and it's completely wrong. We call that hallucination, and it's one of the biggest, most confusing puzzles in AI right now. But what if it's not a puzzle to be solved? What if it's not a bug at all? Okay, let's get into it. This is the big question, right? We pour all this effort into building these incredibly logical, fact-based machines, and yet they just seem to have this bizarre little habit of, well, inventing things out of thin air. It really feels like a glitch, a bug in the system that we just need to find and squash. And for the longest time, that's exactly how the entire industry has been treating it. I mean, the technical definition frames it as a defect. It's an error, a bug, something that's broken and needs to be fixed. The whole goal has been to tune it, train it, and basically engineer it completely out of existence. But here's a really fascinating, kind of mind-bending idea from a researcher named Myung-Ho Kim. What if hallucination isn't some flaw that we can just patch with a software update? What if it's an unavoidable, built-in side effect of the very process that makes these models so intelligent in the first place? And that thought leads us straight to this framework he calls the intelligence triad. It's a totally different way of looking at how these models work, and it completely reframes the whole hallucination problem. Instead of being a random error, it's actually the third and final step in a logical three-part process. So think of it like a three-step dance. First, you have compression. The AI takes the entire internet, a truly mind-boggling amount of data, and squishes it down into a manageable size. Second, it uses those compressed patterns to generalize. This is the magic part, right? It lets the AI answer questions and handle tasks it's never explicitly seen before. But that very act of filling in the blanks, of generalizing, well, that leads directly and inevitably to the third step, hallucination. Here's a great way to think about it. Imagine trying to zip up every book in the Library of Congress into a tiny file that fits on your phone. You're going to have to use what's called lossy compression, which means, yeah, some details are just going to get lost along the way. It's unavoidable. So when you ask the AI to pull up a fact, it isn't just finding a file. It's literally reconstructing the answer from that compressed data. And if a word or a fact is missing from that compressed file, well, it has to make a highly educated guess based on all the patterns it knows. And that guess, that's a hallucination. Now, here's where it gets really wild. This process is actually super familiar. Our own brains do almost the exact same thing. Psychologists have known for ages that human memory isn't like a video recording, it's reconstructive. We remember key details and our brain just fills in the rest with what seems plausible. That's exactly how we end up with false memories. So an AI hallucinating isn't some strange alien computer glitch. It's working on a principle that's surprisingly and maybe a little eerily similar to our own imperfect minds. And this isn't just a clever comparison either. This whole idea is actually backed up by some of the most fundamental laws of mathematics and information theory. There are, for all intents and purposes, unbreakable rules of the universe that make hallucination a mathematical certainty. You've got these absolute giants of information theory, Kolmogorov, Chaitin, Shannon, and their work all points to the same profound truth. Each in their own way, they prove that any system that tries to summarize or abstract information has to lose some of that information. It's just not possible to compress complex data perfectly and then expect to rebuild it with 100% accuracy every single time. It's a mathematical impossibility. And for AI, that means a certain amount of distortion, what we call hallucination, is literally baked into its DNA. Okay, so if we accept that making things up is just a fundamental part of how these AIs work, what on earth does that mean for us? This is where we shift from the cool theory to the very real practical consequences, because we're already using these systems for some pretty high-stakes stuff. And the risks are huge. I mean, think about misuse. An AI hallucinating a legal precedent in a court case or a medical diagnosis for a patient. That could be catastrophic. Then you have misattribution, where it just invents sources, makes up fake quotes, or confidently impersonates a real person. And maybe the scariest one is misbelief, the subtle creeping risk that we all just start absorbing these very plausible-sounding lies as truth. This all boils down to a massive crisis of trust. If the very architecture that makes an AI intelligent guarantees it will sometimes be wrong, how can we possibly build a reliable future around it? How are we supposed to tell what's real when our most powerful tools for knowledge are literally designed to occasionally invent reality? So that leads us to the final and frankly the most important question. If we can't get rid of hallucination, what do we do? Well, the answer isn't to just throw our hands up and give up. The answer is to completely change our goal to find a new path forward. And here is the big paradigm shift. The old goal, the impossible dream, was to eliminate hallucination entirely. The new, much more realistic and achievable goal is to manage it. It's about accepting that hallucination is a feature, not a bug, and then building smart systems and guardrails around that fact. So what would a post-hallucination AI actually look like? Well, for starters, it would have what's called epistemic modesty. Basically, the humility to say, I don't know the answer to that. Its outputs would need to be verifiable, so every single claim could be traced back to a real source. It would have to be transparent, clearly communicating how confident it is in its own answers. And it would probably have a hybrid design, combining the creative, pattern-matching power of today's AIs with the rock-solid logical reasoning of older symbolic systems. And that really brings us to this powerful quote that just sums it all up perfectly. Hallucination isn't a disease we need to cure, it's the cost of admission. It's the price we pay for a machine that can actually generalize, create, and reason beyond just spitting back the data it was trained on. So the real question isn't, how do we build an AI that never lies? It's how do we learn to work with an intelligence that is, by its very nature, imperfect, just like us.